Welcome back. In this video, we will be talking about isotopes. In my previous videos, we have discussed the topic of structure of atom. This is last topic of structure of atom, and this is isotopes. What are isotopes? Isotopes are two or more atoms of the same elements. Two or more atoms of the same elements which have different mass numbers. Mean isotopes are the same element. Isotopes are two or more atoms of same element. They have same proton numbers but different masses. Okay, mass number or nucleon number. Like I have two isotopes of chlorine. One is chlorine 17 and 35, and one is 17 and 37. I mean, if I analyze some sample of chlorine, I will be getting two types of masses. Some atoms are lighter and some are a bit heavier. So these are called isotopes of chlorine. Okay? As you can see, both the isotopes have same proton number. They are same element. They have same number of electrons as well, because both have 17 proton. They have 17 electrons. Now, what are their neutrons? If you subtract 35 and 17, you will get 18. One isotope has 18 neutrons and the other has 37 minus 17, 20 neutrons. So isotopes differ only in number of neutrons. Okay, one has more neutron and one has less neutron. They have same electrons. If you see at electronic configuration of these two isotopes, 17 electrons, 2 electrons in first shell, then 8 in the second, and 7 in the third shell. So both of these isotopes have 7 electrons in their outermost shell. It means they will have same chemical properties. Isotopes of an element have same chemical properties because they have same number of electrons in their outermost shell. They only have different physical properties, like one has more mass, one has less mass, one is less dense, one is more dense. Okay, but they have same chemical properties. Uh, but in periodic table or in our calculations, which mass we will use? We will be using 35 or 37? No, rather we will take a weighted average of these isotopes. If atom has two isotopes or three or four or five, whatever they have, we take a weighted average of all those masses. Now have a look how we can calculate the weighted average of isotopes. Okay, to find the relative atomic mass of an element, atomic mass of an element, you need to know two things. For example, if I want to calculate relative atomic mass of chlorine, so I will find how many isotopes it has. It has two isotopes, chlorine 17 and 35, chlorine 17 and 37. So these two isotopes, I also found the masses of these two isotopes, like one is 35, one is 37. The second thing which I need for its calculation, that is its abundance, relative abundance of these elements. Chlorine 35 is found 75% and chlorine 37 is found 25% only. So how I will calculate? I will multiply abundance of one element with its atomic mass plus the abundance of another isotope with its atomic mass and whole divided by 100. In this way, you will get the answer 35.5. Now, 35.5 is not the isotope of any single isotope, rather it is the weighted average of both of the chlorine isotopes. In periodic table, you will find chlorine written like this, 35.5 and 17. So 35.5 is the weighted average of the two isotopes of chlorine. In this way, any other isotope, if you are given and you are asked to calculate its mass, relative atomic mass, you will multiply just its abundance with its mass plus uh, abundance of the other element into its mass divided by 100. In this way, you will get the relative atomic mass of that element. Hope you got this. If you like the content, do share, like, and subscribe our channel. Thank you.